Yes, I managed to record one podcast, so I'm going to try another one after shutting down and cooling a little bit. This is exciting. Um, Now we have to combine our old statements about very slow circulation in the deep ocean and the thermohaline circulation being mostly deep ocean circulation. Uh, Other than directly being able to observe the western boundary currents of the deep water transport, how else can we observe the deep water circulation, thermohaline circulation? We have been looking at these and already mentioned several times that these sorts of homogenization in the vertical at the latitudes where deep waters and bottom waters are formed correspond to the MOC. So we are not directly showing MOC, and that mostly tends to be the case. You look for evidences in temperature distributions, salinity distributions, identify water masses from and where they would have come from, and look for tracers which are conservative and are taken up at the surface and follow the water masses for a long time because they have no other sources and sinks in the ocean. Okay, so here is something we have seen again and again, the zonal mean meridional section of temperature and salinity, and you can identify various water masses in salinity here. For example, the North Atlantic deep water inundating the southern part of the Atlantic Ocean all the way into the Southern Ocean and crossing the equator. The Antarctic intermediate water riding on top of it, crossing the equator as well. This is at about 1 kilometer deep. This is occupying the space between 2 kilometers down all the way to the bottom. And if you remember, the dynamic upwelling, the Ekman divergence in the Southern Ocean pulls up the North Atlantic deep water between the Antarctic intermediate water and the Antarctic bottom water, which is the heavy water. Here are some data from the hydrographic sections, again showing strong stratification with our subtropical bulges upwelling on the equator and the fairly uniform stratification in the deeper ocean. So basically you have very little change here. And hydrographic section always includes temperature and salinity. They are typically measured from CTDs, conductivity, temperature, depth instruments lowered from a ship, for example, or from some other platform, or nowadays we have lots of data from the Argo float, which floats at the bottom of the ocean and comes up and beams the data. So again, you can see the evidence of the Antarctic intermediate water, North Atlantic deep water, and then the Antarctic bottom water at the bottom there. We have already talked about indirect evidence of deep convection via vertical homogenization of the mixed layer, and we have talked about the structure in the thermocline and the doming and the troughing in the subtropical gyres, and these places where we can infer a overall upwelling of the deeper waters getting converted into lighter waters to compensate for the polar sinking and the North Atlantic deep water sinking and so on. So this is showing the oxygen saturation in milliliters per liter. So you can see that the oxygen that is nearly saturated at the surface also gets taken down by the North Atlantic deep water. You have the upwelling and low oxygen regions here because the biology and the respiration controls the subsurface oxygen minimum zones here, which I think we haven't explicitly looked at. But basically, imagine photosynthesis and atmospheric exchanges at the surface. Oxygen is high at the surface. The photosynthesis is consumed by the herbivores and the fish that eat the herbivores and so on. So they respire, use up the oxygen. So you get an oxygen minimum zone at about 1 kilometer. And then oxygen increases again because of this deep water circulation, bringing near surface high concentrations. Look at this one here, 40 milliliters, 50 milliliters per liter, and this is 70 to 80 milliliters per liter. So oxygen profile gives us a good sense, but the Pacific is very different. Pacific is not so ventilated. This is what we would call ventilation, where the surface is seen by some waters which come down into the deeper ocean, whereas the Pacific Ocean doesn't have such a ventilation. So its ventilation is mostly because of the communication and high turbulence and uptake and Antarctic intermediate water formation at the surface in the southern hemisphere, whereas the northern hemisphere has high oxygen, dissolved oxygen at the surface, but the subsurface gets progressively deoxygenated. Oxygen is consumed. So old waters that haven't seen the atmosphere for a long time tend to be depleted in oxygen because the living things are constantly consuming oxygen, and they have evolved to live in various levels of oxygen as well. So that's some evidence of indirect thermohaline circulation features. It's basically impossible to measure it directly. Okay, we will look at some more evidence from tracers in the next podcast, and I hope this again has survived without any buzzing sound from my dying laptop.